In this video, I'll be explaining fusion and fission reactions, and by the end of the video, you should be able to know what's meant by fusion, fission, how both of them compare, how both produce electricity, and what are possible benefits of fusion and difficulties associated with it. Let's start with fission. You may be familiar with nuclear power plants or nuclear bombs. They are both two different variants of the same process of taking a uranium isotope or a unstable isotope and breaking it down to lighter elements, in the process creating energy, radioactive material and neutrons. The radioactive materials being the lighter elements such as barium. So what differentiates how the power plant uses its uranium to how nuclear weapons uses its uranium? To understand that, we have to understand first what's meant by chain reaction. A chain reaction is when you compile the uranium in such a way that when one goes off, it produces a neutrino. This neutrino goes on and breaks another atom, and this atom produces another neutrino, and it goes exponentially. So let's concentrate on how power plants produce electricity. Power plants, when they break down the uranium and energy is released, they direct this energy to heat up water. This water eventually turns into steam. The steam moves turbines and make it spin to produce electricity. So why does nuclear power plant only presents 13% of the world's energy production? It's simply not clean. It produces nuclear material. Nuclear material is hazardous to the environment. It can stay as long as thousands of years. It's still hot. The temperatures of a nuclear material is so high, it needs its own containment methods and containment sites. It's expensive to develop a nuclear power program. You'll need lots of scientists. You need to mine uranium. You need to purify it from imperfections that might slow down the reaction. You need to manage the waste. You need to build construction sites such as the reactor site, the disposable site for nuclear waste. You need to construct massive centrifuges to purify the uranium. Lots of things need to be done to reach your final goal. And when you reach your final goal, it's not the end of the disadvantages. It might fail. Nuclear power plants are prone to disasters. It can melt down, it can explode, as proven by these accidents, the Fukushima site and the Chernobyl site. So we set forth another mission to find a better, a more efficient way, more safer way to produce electricity, and it came as the form of the sun. I can hear someone saying, how can we use the sun to produce electricity? We're not using the sun, but we're using the method that the sun uses, which is fusion. The sun takes hydrogen in its core and under high temperatures and pressures, it fuses it into a heavier element. So hydrogen is the lighter element, and it takes them and fuses them into a heavier element, being helium. So what is the difference, or what's the difference between splitting atoms and fusing atoms? To understand that, or understand what is the difference, you'll need to take a closer look at fusion. As I said, fusion takes lighter elements, in this case it's deuterium and tritium, two forms of hydrogen, and fuses it into helium. And in the process it creates energy and also neutrons. When also put in a chain reaction, this can work as the same as fission, but without creating this nuclear waste or requiring uh, safety precautions, because simply if anything goes wrong, the plasma created by fusing deuterium and tritium will cool off and the reaction will stop right away without causing any troubles or any explosions. So I can hear someone saying, so why is it not ready yet? Why can't I use it to charge my phone or laptop? Great question. As I said, the sun uses its massive pressure to achieve high temperatures. Here on Earth, we don't have this pressure, so we have to get creative. We have to create our own conditions to satisfy the requirements for fusing atoms, which requires lots of electricity. So your input of electricity is higher than your output. When you put electricity to create electricity, or to create high temperatures, the product is a fraction of the initial income, or the initial input. This is why fusion is not on a massive scale or a commercial scale, but it might be soon. Some scientists say that it will always be 30 years away, but only time can prove. And once we also said that about nuclear power plants. And that's it. Thank you for watching, and goodbye.